Hey guys, today I have the awesome opportunity to talk to you about something that's actually going to be really useful in your everyday life when you get out of high school. Today we're talking about compound interest. Now, interest, especially compound interest, shows up in a multitude of ways. When you buy your car, your bank is going to take interest on your loan as the loan goes out. When you take a loan to buy a house, your mortgage has an interest that's going to go up compoundly. Whenever you put money into a Roth IRA or a 401k or to a high yield savings account, it's going to go up by a certain percentage each year, and it's going to compound annually. So what we need to do is we need to break this down to help you make smart financial decisions when you get older. So first off, let's talk about what compound interest is. Compound interest is interest paid on an initial investment called the principal. So that's not like the principal of the school, that is the initial investment. And on previously earned interest. So we start earning interest on the interest that has already been accrued. So if you put money into the stock market and you're making 7% per year, as it goes, you're going to get more and more money each year, which is pretty cool. What you don't want is you don't want this being used against you. You don't want to open up a high rate credit card and rack up all of these expenses on it, because that's going to accrue as well, and it can really beat you down, because while you might get 7% by investing in the stock market, by opening a credit card, those credit card companies, they're going to charge you like 20, 30%. It's insane. So just be smart with that. All right, so let's break down this equation that we have here. So we have my amount equals principal times 1 plus the rate over n to the power of n to n times t. So let's talk about what each one of these pieces are. So first off, my amount. My end, my final, that's what we want. Okay, so that's like where we're getting to. That's where the end is. Principal, that's what we start off with. So if we're talking about putting money into an account, that's what we put there, leave it so it grows. Rate, that's our percentage rate written as a decimal. Now that's really important. We need to remember to write it as a decimal, so that means we need to move the decimal place over twice. And then this is a new thing that you haven't really seen before, this n. That is how often it compounds. So you could have something that compounds monthly or semi-annually or every year, whatever. So if it's annually, that's just once a year. If it's semi-annually, my n is 2, quarterly 4, monthly, it's going to compound every month, and so that's 12. Weekly, there's 52 weeks in a year, and daily, there's 365 days in a year. So that's just how quickly it can compound, all right? And then lastly, t, that's for time in years. So whenever we break down these problems, I want you to write out to the side A, P, R, N, and T. If we can stay organized, these problems are really easy. So now let's read this one. It says you deposit $9,000 in an account that pays 1.46 annual interest. So stop right there. Do we have anything that we can put here? Yeah. We deposit $9,000. So is that the amount that we get at the end, or is that how much we start out with? And that's going to be what we start out with. So my principal is going to be $9,000 in an account that pays 1.46 annual interest. Now, before we write that as our rate, before we write that as our RR, we need to move the decimal place over twice and create a decimal. So it's going to be 0.0146. That's going to be my rate, 0.0146. So there's my rate for this first one. Okay. Now, let's find the balance after 3 years when the interest is compounded quarterly. So find the balance after 3 years when the interest is compounded quarterly. All right. So first off, quarterly. That means that my n is 4, and we're looking for after 3 years. So that means that my t is 3. So let's build out this equation. We're looking for what my final amount is. So I'm going to go A equals 9,000 times 1 plus, okay, so remember this is my equation here, 1 plus my rate, Okay, my rate is going to be 0.0146 divided by my n. My n is 4 times my n, which is 4, times my t, which is 3. All right, so here we go. We have 9,000 times all of this. And what we can do, and this is the cool part, we can plug this into our calculator. My calculator, we're going to plug this in. I'm going to go 9,000, 9 3 zeros, times 1 plus, and I'm going to build a fraction. You don't have to do this, but I'm going to go alpha y equals enter. And that creates a fraction here. And I'm going to go 0.146 on top of the fraction. And we're going to go divided by 4 on the bottom of the fraction. Close our parentheses. Then we're going to go to the power of 4 times 3. So that's the exact same thing that we said my amount is equal to. So I'm going to hit enter. And we get 13,838. Oh, I messed up. So this is something you have to be really careful with. So let's see here. So we're going to type this in again. We're going to go 9,000. See if you can find the mistake before I write it up here. We're going to go plus. We're going to go alpha y equals. And notice what I wrote instead. I wrote 0.146. The correct thing is 0.0146. The reason I knew that was wrong is because my number was way too high. Okay. All right. So divided by 4. Close your parentheses, the power of 4 times 3, hit enter, and there we go. Okay, it makes sense for us to make $400 off of interest. It does not make sense for us to make $4,000 off of interest. So, there you go, $9,402. Okay, $9,402, and that's going to be my answer. We're going to have my amount's going to equal $9,402.21. Okay, number two. Number 2, you are saving for something special and you need to have $3,000 in 3 years. Find the amount you should deposit. So let's first write this out. A, P, R, N, N, T. Okay? So you're saving for something special, and you need to have $3,000 in 3 years. So first off, 3 years, that's my time. And I need to have, at the end, $3,000. Find the amount you should deposit. So what we're looking for is what we start off with. If we can have an account that pays 0.0225. Move our decimal place over twice to get that. And it's going to be compounded monthly, so my N is going to be T. All right, so this time we're looking for the principal. So what we're going to do is we're going to go 3,000 equals my principal times 1 plus 0.0225 over 12 to the power of 12 times 3. All right, so I was able to write out my equation. Now, how do we solve for P? Well, what we can do is we can plug all of this into my calculator, and then we just have another number times P, and then we just divide by that, and we get what P equals. Like, it's really simple. So let's plug that into my calculator, okay? So in my calculator, we're going to go 1 plus 0.0225. Notice how I put the 0 in there this time. Divided by 12. All right. Then we're going to raise that to the power of 12 times 3, and we get that. So that is what's being multiplied to my principal. So let's go back here. And instead of writing it like, I'm just going to go principal times whatever my answer is in my calculator. Okay, I'm not going to leave it alone. We're just going to leave it like that. My principal times whatever my answer is in the calculator. Then, to solve for my principal here, we're going to divide both sides by that answer. Okay, divide both sides by that answer, and we're going to get my principal equals 3,000 divided by my answer. And so if you look at your calculator, There's a couple ways that we can do this. First, and the easiest way is just click up to whatever number you want to divide by, hit enter, and then look at that. It shows right up there. So we're going 3,000 divided by that, hit enter again, and we get our answer, $2,804.36. So my principal is $2,804.36. Okay, so all we got to do is plug that piece in our calculator and then just divide and leave it in your calculator because we don't want to round in the center of the problem. We just want to round to the nearest cent at the end of the problem. All right, here's your last one, number 3. So number 3, if Scott invests $5,000 at 8% compounded quarterly, how long will it be before his investment has grown to $14,000? So once again, here we go. We're going to go A. We're going to go A, P, R, N, and T. So the amount we start with is $5,000. So my principal is $5,000. It's going to be 8%. So that's my rate. Move your decimal place over. Move your decimal place over twice, and it's going to be 0.08. So my rate is going to be 0.08. My N is quarterly, so that means 4 times a year. And my time is what we're looking for. Okay, how long will it be? And lastly, how long will it be until it's grown to $14,000? You know, I'm going to guess that's going to be quite a long time because you're almost tripling your money going from $5,000 to $14,000. Let's write this equation and let's figure this out. So we're going to have 14,000 equals 5,000 times 1 plus 0.08 divided by 4 to the power of 4t. Okay, so here's what we're going to do. All right, first thing, I'm going to do 2 things in this step. First thing I'm going to do is divide both sides by 5,000. Okay, just trust me on this. 14,000 divided by 5,000 is going to be 2.8. All right, so that takes that away. Second thing that I'm going to do is I'm going to take this and plug it into my calculator. Okay, I'm going to go 1 plus 0.08 divided by 4. No, that is not the right thing. Sorry, 1 plus, okay, try that again. 1 plus 0.08 divided by 4. There we go. And we get 1.02. All right, so that's what's going to go inside of this. So we're going to have 1.02 raised to the power of 4t. Now, we're trying to solve for what that t is, and I have an exponential equation. If we're trying to solve for the exponent, and we don't really know what it is, there's only one way to solve this, and that's using logarithms. That's why we've done all this practice. To solve using logarithms, we're going to rewrite this. We're going to go log base 1.02. So log base 1.02 of 2.8 equals 4 times t. Okay? And then we can get even fancier with it, right? I can rewrite this in change of base form so I can plug it into my calculator. So I can go log of 2.8 divided by log of 1.02 equals 4t. Let's plug this into my calculator. All right, so let's go log of 2.8 divided by log of 1.02. And that gives me this really long number. All right, so I'm just going to write answer equals 4t. Now, finally, to get that t by itself, we're going to divide both sides by 4. and I'm going to get t equals whatever it says on my calculator here, my answer divided by 4. My answer divided by 4. And that gives me, you can't see it here, but you can see it up here, 12.998. Okay? And so, how many years does it take? About 12.998, or, if you want to be more specific, about 13 years. Okay? All right, guys, that is part 1 of our compounding interest. Make sure you turn back into part 2. Thanks, guys.